So we want to find an exponential model for this data. We take the values of x and y, and it's not x and y. Take our values of x and y, we do, but we calculate the natural logs of all the y values. So we get a table of natural log of y versus x. And we often use the natural log. Sometimes base 10 logs are more appropriate, sometimes base 2 logs. It doesn't matter a bit. As long as we use the same base when we convert from the natural log equation to the exponential equation. Okay. So our x values remain 1.7, 3, 5, and 6. Our natural logs. A natural log of 1.7 is about 0.47, let's say. And again, I'm estimating, so. And the natural log of 3 is about, I'm going to say about 1.1, okay? And the natural log of 5, visualizing the curve and so forth, should be around 1.6, and the natural log of 6 might be around 1.8. Okay? Those aren't particularly accurate, but we can see what's going on. We're going to do a graph of natural log of y versus x, and our y values are going to go up to 2, because that's of course what we have here. And let's see, could that be 1? Yeah, it's a little high, but estimates are screwed up anyway, so we're going to live with that. So we'll say that there's 0.5 and there's 1.5. Okay, our x values go out to 6, so I'm just going to go out to 8 so I can easily subdivide these intervals. And now I'm going to do a freehand graph. 1.7 would go about here, actually about here, and 0.47 would go about here. So here's one of my points. Now I'm not going to label it. It should be pretty clear that that's 1.7, 0.47, just the way the numbers are. Then I come out to 3 and I get about 1.1. So 1.1 would be about here, 3 is here, so here's another point. Okay. Come out to 5 and I find that I have 1.6. And then I come out to 6 and I find I've got 1.8. And now I've got 4 points that don't really look like they lie on that great of a straight line. Part of that's because my scale isn't quite right. Part of it's because my estimates aren't quite right. But that's fairly typical of data anyway. So the little errors in my estimate, or big errors, whatever they are, and the errors in my sketching of the graph just kind of correspond to the uncertainties you have when you take data. I planted those 6 lettuce plants in a week. Every Monday I'm going to kill one and weigh it. Okay? We'll see what that data looks like here, but maybe, yeah, it'll go past the end of the semester, but I'll post it in case you're interested. And if you aren't, just go out and eat a salad. Okay, now, we're going to we'll see that these points don't lie very well on a straight line. But if I lower that line to about here, maybe I get a pretty good approximation. So let's just say that even though the points don't look like they're all that straight, there is a straight line that does a pretty good job of approximating them. Now, straight line comes down pretty close to the origin, which means that I'm really in dangerous territory here. I'm going to have to estimate a pretty small value, which means that the model I get from estimating is not going to be very good. Okay? If you run this through software and get your regression analysis, you are going to get the slope and the y-intercept of the line, or the natural log y-intercept. But still, as I say, I want you to draw these by hand and make your own estimates. And then go to Excel. You can use Excel. You can use, you know how to use Excel? Yeah, I can actually show you if we have time. But right now, just go with a hand sketch graph and see what it looks like, because I think that's more important than knowing how to use Excel. But we'll spend some time on that next time, so you can then go back and see how well you did. Of course, this means that you're not going to get very good answers. So work it out on paper. And, you know, I'm going to ask you, work it out on paper and send it to me. Don't put it into MyOpenMath yet, okay? And then it'll be very easy to put into MyOpenMath when I show you just a little Excel. Okay, because MyOpenMath is going to be pretty picky about your numbers. You're not going to get good numbers from doing the thing that causes you to really learn this. Okay? I mean, I like MyOpenMath. It does a lot of things well. But sometimes you need a little human judgment on the answers. Okay, so here's our line. It's not going to come out very good. If it does, I'll be shocked, and it will just be luck. Okay? I don't claim any skill here. But it looks like this line has a y-intercept around 0.17. Okay? Lots of questions about that. Those are question marks. Okay? Now the slope, I think we're going to come out a little closer on. Okay? So the slope, again, if I take this point and let's just go ahead and extrapolate this line out to 8, because the further my points are apart, the more accurate my estimate is going to be. Now, that's 8. That would project over here. And I'm saying that that looks like about 2.6. So without writing out the details of, I'm not going to say what the coordinates of these points are, but it's clearly, this is 8, 2.6. And this is 0.17. So my rise is this, and my run is 8. And that's going to be 2.43 over 8, which is about 0.34. Okay. So now using this number and this number, we see that the natural log of y equals 0.34 times x plus 0.17. Well, that means that y is approximately equal to e to the 0.34 x, e to the 1.7 to 0.17. Okay? And e to the 0.17 is pretty close to 1.2. And e to the 0.34, what do you cube to get 2.7? Let's see, 1.3 is too little, 1.4 is about right. So I'm going to say it's about 1.4 to the x. Yeah, I assume you can get from this step to this step because we did that in a little more detail in the last example. Okay? So, how's that going to match this? And my answer is not very well. Okay, but that's the process. I can't imagine why it came out that badly. Oh, I know what's wrong. I was taking the natural log of these numbers, not these numbers. Okay? So, yeah, that's pretty bad. Okay? So I did it all wrong.
Well, I get your process and I get the idea.
Yes, I know you do. I can tell by the look on your face.
I still don't understand how to convert a table into just the data from the table into
The graph. Yeah. Data on the table to the data, natural log versus x. Okay? And that gives you the graph. You find the straight line. Okay? Yeah. So my values should have been like, let's just do this briefly. Natural log of 3 should have been about 2.1. Natural log of 1.7. No, it's not 1.7, it's 3. I'm trying to do it again. Okay, natural log of 3 is about 1.1. Natural log of 7 is about 2. Natural log of 35 is about 16. 2.6 maybe. And wait a minute. Be 3. Don't think that's very accurate. Natural log of 60, you got about 16 times 7, or 16 times 3. I'm going to say,
Can I help?
I'm going to 2.6 here and I'm going to 3.6 here. So if you do the graph, I'm sorry, you said something.
I was going to say, using the calculator, natural log of 60 is 4.094.
4,
So
16 times 16 would be the third power. Oh yeah, 6. Okay. Well, I'm going to go with these numbers. They're not that far off, but I don't know why I'm that low, but Okay. So anyhow, we come out to 6 here, and we get 3.6. At 1.7, which would be about here. We get like 1.1, so 1 would be here, 1.1. And then we get a couple of points in between here. We don't just use these 2 points, we use all the points and we adjust our line. Notice that this line didn't exactly go through any of the points. And the actual regression line, unless you have a perfect model, well, for real data, it can never actually go through all the points. Okay? That doesn't mean you try to avoid going through all the points, but you make your honest estimate of where these points, or where this line should be, so that you get as close as possible to on the average to the points. Okay? So that's what you do, but I'm just going with this, and I'm saying the slope ought to be then about 2.5 over 5. So slope is about 1/2. And the y-intercept is about 0.3. And that would give you a model of about 1.3 times e to the 0.5, which is about 1.7 to the x. Okay? So and that model really isn't too awful bad. It's not too awful good either. Okay? So, you can do that, and that would be the corrected process. I just wanted to put that on there so you didn't actually believe this. Also, I noticed, I think we had enough of the board here. The only thing we couldn't see is these wrong values, but there they are for all the world to see. Okay. Okay, good.